Deductions from Henkel transformation of derivatives of a function. So deduction is continuous, right? We already finished 3 deductions, deduction 1, 2, 3, right? Now we are going to see the 4th deduction. We know that if fn bar of p be the Henkel transformation of order n of the function f of x, and fn dash bar of p is the Henkel transformation of f dash of x, then fn dash bar of p, which is equal to minus p by 2n n plus 1 fn minus 1 bar of p minus n minus 1 fn plus 1 bar of p. That is equation number 1. So next deduction, prove that f double dash bar n of p, which is equal to p squared by 4 n plus 1 by n minus 1 fn minus 2 bar of p minus 2 n square minus 3 by n square minus 1 fn bar of p plus n minus 1 by n plus 1 fn plus 2 bar of p. So replace f by f dash in equation number 1. So replacing f by f dash and f dash by f double dash automatically, right? So f dash of n becomes f double dash of n bar of p, right? Which is equal to minus p into n plus 1 by 2n f n minus 1 dash bar of p minus n minus 1 by 2n f n plus 1 dash bar of p. That is equation number 2. Now replace n by n minus 1 in equation number 1. So f n minus 1 dash bar of p, which is equal to minus p n minus 1 plus 1 by 2 into n minus 1 f n minus 1 bar of p minus n minus 1 minus 1 by 2 n minus 1 f n minus 1 plus 1 bar of p, which is equal to minus p n by 2 n minus 1 f n minus 2 bar of p minus n minus 2 by 2 into n minus 1 f n bar of p. That is equation number 3. Now again you are replacing n by n plus 1, right, in equation number 1. So f n plus 1 dash bar of p, which is equal to minus p n plus 1 by 2 into n plus 1 f n plus 1 minus 1 bar of p minus n plus 1 minus 1 by 2 n plus 1 f n plus 1 bar of p. So which is equal to minus p into n plus 2 by 2 into n plus 1 f n dash f n bar of p minus n by 2 n plus 1 f n plus 2 bar of p. That is equation number 4. So now we are going to substitute 3 and 4, the values of f n minus 1 dash bar of p and f n plus 1 dash bar of p in equation number 2. So we will get f double dash n bar of p, which is equal to minus p into n plus 1 by 2n minus p into n by 2 n minus 1 f n minus 2 bar of p minus n minus 2 by 2 n minus 1 f n bar of p minus n minus 1 by 2 n. We are taking the second value, that is f n plus 1 dash bar of p value minus p into n plus 2 by 2 n plus 1 f n dash bar of p minus n by 2 n plus 1 f n plus 2 dash n plus 2 bar of p, which is equal to, so p is common, minus p we are taking outside, so minus p into minus p square. So first term n into n plus 1 by 2n into 2 into n minus 1 4n into n minus 1 f n minus 2 bar of p. Next term minus, right, minus n plus 1 into n minus 2 numerator 2n into 2 into n minus 1, that is 4n n minus 1 denominator fn bar of p minus next term n minus 1 into n plus 2 numerator denominator 2n into 2 4n into n plus 1 fn bar of p plus last term n minus 1 into n numerator 2n into 2 4n into n plus 1 fn plus 2 bar of p denominator into denominator 4n into n plus 1 denominator into fn plus 2 bar of p, which is equal to p squared by 4 n into n plus 1. We are taking 1 by 4 outside, right, n into n plus 1 by n into n minus 1. We can cancel n and n numerator denominator also. We'll see in the next step, right? fn minus 2 bar of p minus n plus 1 into n minus 2 by n into n minus 1 f n bar of p minus n minus 1 into n plus 2 by n into n plus 1 fn bar of p plus n into n minus 1 by n into n plus 1 fn plus 2 bar of p. So it is equal to p square by 4. So n and n cancel, numerator and denominator. N plus 1 by n minus 1 fn minus 2 bar of p minus this second and third term minus fn bar of p is common. Take it outside. So minus, so remaining term n plus 1 into n minus 2 by n into n minus 1. Second term. Third term n minus 1 into n plus 2 by n into n plus 1. So fn bar of p be outside, right? Plus n minus 1 by n plus 1 fn plus 2 bar of p, which is equal to p square by 4 n plus 1 by n minus 1 fn minus 2 bar of p minus, we are taking LCM, common LCM, n into n minus 1 into n plus 2, n plus 1. So cross multiplying, right? So because in denominator you don't have n plus 1 in the first term, so we are multiplying n plus 1, right, the numerator of the second term. So n plus 1 into n plus 1 n plus 1 square into n minus 2 plus, similarly you don't have the n minus 1 in the denominator of the second term, right? That is right. So we are multiplying with n minus 1. So n minus 1 into n minus 1 square into n plus 2 all divided by n into n minus 1 into n plus 1 into fn bar of p plus n minus 1 by n plus 1 fn plus 2 bar of p, which is equal to p square by 4 n plus 1 by n minus 1 fn minus 2 bar of p minus, using a plus b whole square formula, n square plus 2n plus 1 into n minus 2 plus, now we are using a minus b whole square formula, n square minus 2n plus 1 by n plus 2 whole divided by n into n minus 1 into n plus 1 fn bar of p plus n minus 1 by n plus 1 fn plus 2 bar of p, p square by 4 n plus 1 by n minus 1 fn minus 2 bar of p minus, so we are removing the brackets, we are simplifying. First multiply with n to first term, n into n square n cube, n into 2n 2n square, n into 1 n. Next multiply with minus 2, minus 2 into n square minus 2n square, minus 2 into 2n minus 4n, minus 2 into 1 minus 2. Next n into n square n cube, minus 2n into n minus 2n square, then n into plus 1 n, then plus 2 into n square 2n square, 2 into minus 2n minus 4n plus 1 into 2 whole divided by n into n minus 1 into n plus 1 fn bar of p plus n minus 1 by n plus 1 fn plus 2 bar of p is equal to p square by 4 n plus 1 by n minus 1 fn minus 2 bar of p minus grouping. So n cube plus n cube 2n cube. So totally we are having minus 4n plus 2n minus 4n, right? So minus 4n, keep it as it is. So minus 4n plus 2n becomes minus 2n. So that is what we have written, minus 2n minus 4n divided by n into n minus 1 into n plus 1 fn bar of p plus n minus 1 by n plus 1 fn plus 2 bar of p. So minus 2n minus 4n you can write minus 6n. So we are taking 2n outside from that term. So which is equal to p square by 4 n plus 1 by n minus 1 fn minus 2 bar of p minus, we are taking 2n outside, so n square minus 3, right? N divided by n into n minus 1 into n plus 1 fn bar of p plus n minus 1 by n plus 1 fn plus 2 bar of p. So in the second term n and n, numerator and denominator get cancelled, so remaining, therefore f double dash bar of n p of p, which is equal to p square by 4 n plus 1 by n minus 1 fn minus 2 bar of p minus 2 n square minus 3 by n square, n into n minus 1 into n plus 1, we are grouping that, we are using a square minus b square formula, which is nothing but n square minus 1 in the denominator, fn bar of p plus n minus 1 by n plus 1 fn plus 2 bar of p, which is to be proved. Thanks.